Good afternoon, grade 8s. I hope you are all doing well. I hope that you are preparing and getting ready for your exams that is coming up very soon. We are going to take this opportunity to look at the revision exercise that we covered in class over the last few days. The revision exercise was dealing with geometry, some geometry questions. We had some quadrilaterals, some triangles, and geometry of straight lines all mixed together. It was question 1, I think it's on the screen now, and then question 2, 3, and then also question 4. So we'll use this video, hopefully just the one video, to look at all 4 questions, or I'll break it up into 2 or 3 videos so that it's not too long. This is also the first time that we are trying this out with me being in the screen. Actually had some of you request that previously, so I don't know, hopefully this helps when I explain things, that you seeing me physically in the video, that might help to drive the point home. So let's see if that works, and let's get straight to it. Alright, so we've got a screenshot here from the exercise as it was written on the board, and as you can clearly see, we've got the instruction. So the instruction is calculate the sizes of the unknown angles and give reasons for your answers. So question 1a, as we can see here, is a quadrilateral. It is quadrilateral A, B, C, and D. So A, B, C, D, that's the quadrilateral. And we are asked to calculate the sizes of the unknown angles. In other words, in this case for 1a, the unknown angle would be over here, that is angle B, and angle B of course is labeled as X, in other words it's unknown. The other angles, A is 90, D is 90, C is 75, and of course B is unknown. Now your approach that I've noticed in class is that the first thing that everyone jumps to with this problem is that this is a rectangle, which it's not. Now the only thing that we can see from this diagram is the fact that it is a quadrilateral. That is the only evidence there is, and that is the fact that it's a 4-sided figure, so a figure with 4 sides, and it is a quadrilateral. There's no evidence to suggest that this is a rectangle, because we've got a 75-degree angle here, which immediately rules it out as a rectangle, because a rectangle is a quadrilateral with all 4 angles being equal to 90. And if one of them is not 90, so I made that there, but that doesn't mean it's 90, because obviously it's 75. So if at least one of them is not 90, it means this is not a rectangle. It immediately disqualifies it as a rectangle. Then a lot of you also went to, well, if it's not a rectangle, it must be a parallelogram. Well, there's no evidence to suggest that this is a parallelogram either, because unless they gave you these little arrows on that side there and there, that would at least have told you that this is a parallelogram, if it were the case, but it's not. We cannot assume that these guys are parallel. We cannot assume that they are parallel, because the arrows, the symbols have not been given to us. Oh, by the way, if you're hearing any voices in the background, I apologize. I am recording this in my classroom, and there of course are people outside wandering and talking and screaming and shouting. So we'll try to hopefully keep that at a minimum, and hopefully my voice comes through properly during this recording. So just to clarify, this is not a rectangle because of the 75-degree angle. It is not a parallelogram because there's no evidence of that. Why? Because we do not see arrows on the 2 pairs of opposite sides, which means basically it also cancels it out to be a square. This is definitely not a square, simply because of the 75-degree angle again. It is not a rhombus because there's no evidence to suggest that this is a rhombus. Why? Because again of the parallel sides. I mean that would have helped towards proving that this is a rhombus if it could, but it's not. It's not a trapezium either. First of all, it's not a trapezium either. Again, because of the one pair of opposite sides not shown to be parallel. and it is definitely not a kite. So it's none of those 6 quadrilaterals that you've studied and learned the properties of. It doesn't have to be one of those, and that is the point I want to drive home here. This is simply a quadrilateral. It is a quadrilateral because it has 4 sides. That is the only evidence that is presented here. The fact that A, B, C, D is a quadrilateral. That's it. So we are asked to calculate the sizes of the angles. So you don't need the properties of any of those special quads in order to find the size of this angle, because we know that the sum of the interior angles of any quadrilateral is equal to 360 or 360 degrees. So I can then say in the quadrilateral ABCD that angle A, let's do it like this: angle A plus angle B plus angle C plus angle D, they must add up to 360 degrees. Let's just add more space here. The reason is sum of interior angles of quadrilateral. Okay, so that then means I simply need to substitute my values for A, B, C, and D, and then solve for the unknown. So angle A, of course, is 90 degrees. Angle B is X. Angle C is 75 degrees. Angle D is 90 degrees. And that is all equal to 360. So at this point, you have gained yourself 2 marks, usually for making a statement, and then also giving a reason for why you made that statement. That's already 2 marks in your test and exams. Now all that's left to do is to solve the equation. I will then add up all the values. So I've got here, I've got 90, 75, and 90. Okay, so if I take 90 degrees and I add 75 degrees and I add 90 degrees, I get a total of 255 degrees. So that means I have here X plus 255 degrees is equal to 360 degrees. Then I take the 255 over, I take it over, or what I'm doing actually is subtracting 255 degrees from both sides of the equation. So that obviously means that 255 will be taken away from the left hand side to make it 0, and on the right hand side I have 360 degrees minus 255, and on my calculator I've got 360 minus 255, and that gives me 105 degrees, and that is my value for X. So coming back to this sketch here, I've simply taken these 4 angles. This is also an angle, it's just not known, and I've added them together, put them equal to 360 or 360 degrees, and then I use that equation to calculate the value of X. I did not need any special quadrilateral properties to do this. I simply needed the property of the interior angles of a quadrilateral adding up to 360 degrees.